far out near the edge of the solar system, where the sun's light is weak, lies a world that until recently was completely unexplored.
Pluto is the Everest of the solar system, the farthest and coldest and hardest to reach.
By going to Pluto, we were looking beyond the known solar system and exploring a whole new world.
This is the story of Pluto's exploration and what was found there, told by those who dared to do it.
We good?
I need water for answering this question.
Okay, I'll give you my personal opinion on this.
A mission 25 years in the making, attempting to discover our most ancient origins.
This mission represents the spirit of adventure and discovery and inquiry which is inherent in the human spirit.
Which is our insatiable desire to explore the unknown and understand how we fit into this vast universe.
We have ignition and we have liftoff.
There really is something intrinsic in humans to want to explore.
You can look at it from an evolutionary perspective. We didn't have the sharpest claws or the strongest muscles, but we had this ability to invent and explore, and, we had curiosity.
That's how we've come to exist all over this planet, and that impulse doesn't stop at Earth.
The exploration of the outer solar system began in the 1970s. And in 1977, a pair of spacecraft called Voyager 1 and Voyager 2 set off to visit the most distant planets, including Uranus and Neptune. Voyager 2 was the first to leave Earth.
5, 4, 3, 2, 1. We have ignition and we have liftoff. The first of 2 Voyager spacecraft to extend man's senses farther into the solar system than ever before.
The mission would fly past Jupiter, then Saturn, before heading for the mysterious outer worlds.
The Voyager mission was an incredible adventure because it was our first time to really visit all these worlds and start to get to know their systems, not just the planets themselves, but their moons. Those of us that were involved felt almost as though we were on board the spacecraft looking out the little window when the images came up on the screen, and for the first time you're seeing these new worlds. When we first visit these planets, they're flybys. You're not going into orbit, you're not landing. It's just a very quick visit in it. You see it approaching, and then all of a sudden, there it is, and then it's in the rearview mirror, and you can't stop, and you're still going. So there's something about the pace of discovery that's amazing.
The first pictures of Uranus were a little bit boring, and people were a little worried about the lack of jazziness. Uranus is a weird planet. Instead of spinning, like we're spinning 23.5 degrees from vertical, Uranus is on its side, tipped on its side. Why? We don't know. Very strange, unlike all the other planets. Could it have been wanged by something going by, tipping it over? We don't know.
Systems ready to control. We see lockup on the green box on wideband.
September 1989, we're about to arrive at Neptune.
Copy this, thank you. Temperature.
Again, it's sort of cold and dim, but Neptune is really a little bit more interesting than Uranus. We see a blue atmosphere, dark, deep clouds, and then some white clouds above. So there's a lot more structure than at Uranus. But perhaps the most important thing about Neptune's system is the big moon, Triton.
We are pretty sure at this point that Triton formed orbiting the Sun just as Pluto did, and somehow early in the solar system it got captured into orbit around Neptune. We saw landscapes like nothing we had ever seen before, looked like melted wax. It was clearly a very active world. There weren't many craters, so things had been happening very recently.
The most exciting thing and the weird thing that we saw were black plumes of smoke coming up out of some hole. So clearly, there's some geological activity going on here.
And so Triton just instantly became this incredibly complex world.
And seeing that, which was thought sort of to be a twin of Pluto, I think got a lot of people thinking, well, wait a minute, there are other worlds out there.
For many of us, it was, now what? What are we going to do after Voyager? Is there life after Voyager? I was lucky because a young man called Alan Stern, he was a graduate student, came up to me and said, "What about Pluto? I think we should go to Pluto."
After Voyager had this smashing success all the way across the solar system, the United States Postal Service issued a set of stamps. And on each stamp, they featured the spacecraft and mission that had been first to that planet. But for Pluto, there had been no exploration. So they had this lame stamp. And that stamp became a dare that we should finish this off. We should make this happen. We should change this stamp.
I knew there was a chance that in my lifetime, in my career, we could send a space probe off to Pluto.
What we didn't know is we were embarking on an adventure that would last most of our careers.
This path to Pluto all began with Clyde Tombaugh.
Clyde Tombaugh was an amazing person.
The United States was in the grip of a paralyzing depression. Millions were unemployed, on some form of relief.
He grew up very poor on a farm in Kansas during the Depression, and as a young kid became enthralled with astronomy and was self-taught from the local library.
In 1928, the young farmer built a telescope using the crankshaft of an old Buick and pieces of farm equipment.
He dreamed of being an astronomer, but had no plan, no idea how this poor kid in Depression-era Kansas could ever get off the farm.
Well, I was interested in knowledge. And so, of course, I was fascinated with what I saw in the sky. And so I made drawings of Mars and Jupiter.
Tombaugh sent his drawings off to the Lowell Observatory in Arizona, who were so impressed by his work that they offered him a job.
The job was to go off to search for the planet out beyond Neptune.
For decades, there'd been a theory about a hidden planet out beyond Neptune. Percival Lowell, a wealthy businessman and astronomer, had become obsessed with the theory and spent the latter part of his life searching for the mysterious planet, but never found it. After his death in 1916, the Lowell Observatory that he founded continued the search.
They had been trying early years to find it, but without any success. And they weren't doing too thorough a job of it either. You have to have a very strong mental concentration, otherwise you can't let your mind wander. You've got to be conscious of seeing every star image to see if it shifts. And that's very demanding.
It was a difficult, painstaking task with little chance of success. Tombaugh used the telescope to photograph a tiny patch of sky onto glass plates. He studied these images on a special machine in the hope that he would spot the mysterious planet as it moved. But after searching for nearly a year, he'd found nothing.
A lot of people told him it was futile and that they would never find it, and people had already looked. But he was incredibly fastidious.
Then, on February 18th, 1930, while comparing two photographic plates taken in late January, 6 days apart, he noticed a moving object. He checked it again. He photographed the patch of sky a third time. That's when he realized he had found a 9th planet beyond Neptune.
And then they announced it to the world.
Well, I think I decided to let the younger men do it now, but I feel quite satisfied with what I did in my lifetime.
Clyde passed away in 1997, and he said if a mission to Pluto ever got launched and there was a way for his ashes to be flown in the spacecraft, he would really like that to happen.
There's lots of interesting things we can do. Perhaps the most important thing is to look at what Voyager did not do. It did not visit Pluto.
When we were campaigning for this mission to Pluto, there was a big establishment, the Voyager types, the Cassini types, the Galileo types who were pushing for those really big missions. What we wanted was a lot smaller, just to fly out, take a few pictures of Pluto.
However, there's the political problem of trying to sell a mission that will have a 14-year cruise, will not return information for 14 years, and when it does, it'll be a half-hour flyby with a handful of pictures. You're not going to have 11 instruments. You're not going to have the data-taking capability of Voyager. But remember those 9 pictures of Triton. We have to cut back our scientific desires to have more and just send it out and take those pictures.
It was really a group of young scientists who wanted to ask NASA, why aren't we going to the last of the planets?
And so it was a bit of an underground movement of people who were pushing for this underdog, Pluto.
So we called ourselves the Pluto Underground. Our first objective as the Pluto Underground was to have NASA do a study of how you go about flying a mission to explore Pluto. In May of 1989, I went to the top of the NASA Planetary Exploration Program to a man named Jeff Briggs and just straight out asked him, how about a study of how to go explore the last of the planets? And to my complete surprise, he smiled and said, you know, that's a brilliant idea. No one has ever asked me that before. I think we should study it.
A study was just the first step on a very long road to making a mission happen. The Pluto Underground had to research the idea and devise a plan that showed how a mission would actually work.
It's exciting to Mark and I and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet. We had no idea how complicated the political process would be.
We would walk into one of these meetings and the NASA representative would say, okay, this is the mission you're going to get. And our job was to justify that mission concept. And most of them were absolutely crazy schemes.
Let's do a small mission. Let's do a grandiose mission. Let's do a cheap mission. Let's fly two.
No, we don't want to do that. But if we say no, then we're done.
Every year, something came up that prevented us, that blocked us, that we had to find a way around. We were close, but then we were set back. We were even closer, then we were set back. And what made it even more difficult was the feedback that we would get that you guys really should let go of this. There must be other things that you're interested in doing.
I met Dave as a graduate student, and he was a professor, and I needed a project to work on.
And she came to me one day and said, you know, Dave, the thing I'm working on is not going that well. Have you got any ideas? And I said, yeah, I've been thinking about searching for things beyond Saturn. And she said, okay, that'll be cool.
Dave pointed out that the outer solar system seemed rather empty compared to the inner solar system.
Inside Saturn, inside Jupiter, we knew of lots of asteroids and comets and all the planets. And then beyond Saturn, nothing much, just Uranus, Neptune, and Pluto.
So he proposed that maybe we should look in the outer solar system to see if there were things out there.
Dave and Jane used the Mauna Kea Observatory here in Hawaii.
Mauna Kea is 14,000 feet high. It's above most of the clouds. It's above most of the water vapor in the atmosphere. It's the second best place to put a telescope. First best would be in space.
The telescope on the peak, 4,000 meters, is miserable there because at that level, the amount of oxygen that you get is only about 60% of what you get at sea level, so you don't have enough air to breathe.
The altitude gives me a headache every time. Sometimes you would get a nosebleed. Once Jane Lou collapsed from the altitude. We never found out why, but she simply couldn't stand up.
It's painful to work on Mauna Kea, but we put up with it because we understand that this is the best place to make observations. Everybody wondered where the cutoff point was. So many people would say, when are you going to stop? We were looking for things that were not predicted to exist by any theory.
So we take a series of pictures, 4 pictures, one after the other. And the stars and the galaxies, which are basically infinitely far away, don't move. But anything in the solar system moves because it's going around the sun. And the speed depends on its distance. And we look for anything that is moving slowly with respect to the stars and the galaxies.
Every time we wanted to stop, the technology would get better.
And we knew the technology was improving because bigger cameras became available to us year by year. At the end of August in 1992, we took the first picture and it came out. Then the second picture came out. And I pretty much immediately saw this object that seemed to move, and it didn't move much. And I said to Jane, hey, Jane, come and have a look at this. And she said, yeah, that looks good.
We were very excited because it was the first believable candidate.
So the third picture came, and the third picture showed that same object, but a little bit further over. And so we suddenly thought, hey, that's probably the best thing we've ever seen after doing this thing for ages, for years. So the fourth image came out, and it was just perfect. It was bang, 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 in a straight line going to the west. And during the whole time, we were able to measure it, and its speed was just a beautiful straight line. How could that possibly be real? Like, we've done this so much, and there's just so much rubbish that we get. How could this possibly be real? So we just took picture after picture after picture after picture for the remaining 6 hours of the night.
Wow, this changes our view of the solar system fundamentally, that there's a whole new unexplored area out there of objects. It was really clear that this was a major breakthrough.
There are 100,000 objects in the Kuiper Belt bigger than 60 miles across. And there's 1 billion objects in the Kuiper Belt bigger than about a mile across.
Pluto is not just some weird fringe oddball by itself out in the outer fringes of the solar system, but in fact was the largest member of this massive domain of objects that clearly is important in the story of how the solar system came to be.
The competition was really intense. 5 teams formed, and frankly, of the 5, our team was the David in a David and Goliath battle. We had the least experience, but probably the highest motivation. No humans really could glimpse as a real planet. One of the first things that we had to do was to find a name for it. And when I was on a long run across my hometown, Boulder, Colorado, and I turned around to the west and saw the Rocky Mountains. And I thought, this is a mission of New Horizons. And people liked it, and that's what we adopted.
We designed our mission as best we could. Not too much, but not too little. Just get it right.
These proposals are phone book thick, engineering and technical documents. There's a lot of work that goes into putting one of these together. On November the 29th, 2001, after 300 days of competition, I was at a planetary science meeting, and NASA scientists came to me and said, there's a phone call for you. And I knew at that moment that that phone call was the decision. We would find out if we had won or lost. And I picked up the phone, and time telescoped. It slowed down for me incredibly, and I knew that within moments, my life would change, one way or the other. And fortunately, the phone call was a good one, and we found out we had won.
It was such a huge relief. We were selected. It was all systems go to build the spacecraft and to make it happen.
David had beat Goliath, and we were actually going to have an opportunity to do something that had been our ambition for 14 years.
Then they actually have to build it and make it succeed, and they're on a ticking clock.
All of the challenges associated with building a spacecraft that was small enough, used little enough power that we could perform when the light levels are so low, it was just technically very challenging.
Well, you know, the key to planetary science is that you really have to go places to get the resolution, to get up close enough to really see what's going on. We want to get up close and personal.
I was so excited when I had the opportunity to join this mission. I had been studying Pluto for years using ground-based telescopes, trying to understand what was going on in this fuzzy point of light.
The Hubble telescope produced the first image that illuminated Pluto. This image was made up of just 8 pixels, 1 pixel per 390 square kilometers of Pluto's surface.
And to be able to have a part in the New Horizons mission where we got to turn Pluto from a point of light into a world where we're mapping the surface is amazing.
We were ready for launch. We had the spacecraft on top of the rocket.
The New Horizons spacecraft is a small spacecraft, and then we put it on the biggest rocket that we had available from NASA at the time, the Atlas V.
They put a stamp on there from the U.S. Postal Service that says Pluto not yet explored. In addition to a small vial of ashes from the remains of Clyde Tombaugh.
It was my honor to be able to bring it back to his efforts to actually find the planet.
We had a number of days where everything's lining up, and then somewhere along the way, somebody said, no, can't go. That got to be the pattern.
11, 10, 9, 8, 7, 6.
I remember on that one day, the clock's counting down, and it's getting lower and lower, and they're not stopping it. And I said, wow, if they don't stop this, it's actually they're going to have to send it off.
6, 5, 4, 3, 2, 1. We have ignition.
And sure enough, that thing took off like nobody's business.
We had a picture-perfect launch. At 11 p.m., I was out on the balcony of the hotel where I was staying in Cape Canaveral, just looking up and seeing a beautiful, bright moon, and the spacecraft was passing, at the orbit of the moon at that time already. And it usually took the Apollo astronauts 3 days to get there. So we knew we were speeding on to our destination.
Flying past Jupiter allowed us to check out our instruments.
New Horizons flew by Jupiter and took advantage of a particular trick called a gravity assist. So if you imagine Jupiter moving along and New Horizons is catching up to it, and Jupiter pulls it forward and then bends the orbit, and as they keep going, that interchange will add a little bit more velocity to the speed of New Horizons.
Spacecraft is outward bound from Jupiter, and we're on our way to Pluto.
Congratulations. All right.
We shaved a couple of years off the flight time, but it was still a very long haul.
It was another 8 years from there to Pluto. So they pioneered this technique of hibernation, where you put the spacecraft to sleep first for a day, and then for a week, and then for weeks. Which makes a lot of sense because you think of the wear and tear on all the components. It's more likely to be working after 9 years if it's been off most of the time. And it's just sending back a beacon, a beep.
Pluto is a planet. Pluto is a planet.
I want to know that if it really is a planet or if it's just something else in space.
There was this issue about what a planet should or shouldn't be and whether Pluto was one.
I don't think it's a planet. I really don't. There's a bunch of objects like that out there, so how did that get to be a planet, you know?
Didn't seem right to call Pluto a planet when there were like thousands of other objects like it.
It's a big Kuiper Belt object, but it's a Kuiper Belt object. There's no doubt about that.
And so the astronomers had a vote, which is ludicrous in itself. They had a vote on whether Pluto was a planet. And the idea of voting in science, it's just crazy. Since when do we vote about scientific facts?
In the scientific community, most planetary scientists simply ignore it.
To me, it wasn't a big deal. I knew Pluto was an amazing place and I couldn't wait to see it, and what we called it was pretty secondary.
Dwarf people are people, dwarf planets are planets.
Because it's a flyby mission, we knew we were going to get a really good shot at one half of Pluto. The other half, we would see it, but it would be blurry. One of the projects I worked on was to take images with the Hubble Space Telescope and figured out a map. But Pluto is so far away and so tiny that even with Hubble, it's very, very difficult to get any information. It took about 6 or 7 years worth of computer processing to get the maps out. I think this map is probably the best map we're going to get prior to the spacecraft getting there. I said, here's the deal. I can tell you right now where you need to go. There's one patch of Pluto that's the brightest part of the body. Right next to it is one of the darkest areas on the entire surface. You're going to see the darkest stuff, you're going to see the brightest stuff, and you're going to see the contact in between, and then all of the northern polar areas.
On July the 4th, 2015, New Horizons had been journeying towards Pluto for over 9 years. It was now just 10 days from reaching the planet. As the country celebrated Independence Day, Alice Bowman, the mission operation manager, was in mission control, preparing to upload the main flyby sequence that would direct New Horizons towards Pluto.
There are a number of gates that we go through when we establish communications with the spacecraft. You know, you see the first gate locked, the second gate locked, the third gate locked, and that's when you get your telemetry.
But at 1:54 in the afternoon, their worst fears came true.
We went out of lock, the next one went out of lock, and then we lost the last one out of lock.
I got a phone call from our project manager saying something I almost couldn't process the words for. He said to me, "Alan, we've lost contact with the spacecraft."
I had people that were very upset that I needed to calm down and have them focus because I needed their expertise.
Just over an hour later, at 11 minutes past 3 in the afternoon, the team re-established communication with New Horizons. But the problems were far from over.
The spacecraft reports on its status, and it was bad news. The spacecraft had overloaded a computer memory and rebooted itself while this uplink was happening of core commands for the encounter sequence, and all of that software was lost.
The team had just 3 days to rewrite the flyby sequence and upload it to the spacecraft. Otherwise, New Horizons would miss Pluto.
This is the 4th of July, and everybody was taking the holiday off. So people start showing up there in mission control in their bathing suits and flip-flops.
We knew that if we could not fix this problem, that everything we had invested in the previous 26 years, all of that was for nothing unless we could fix the problem.
So it was necessary to reboot the computer and then start rewriting some of that software and finding the right files and reloading those core sequences.
But that process took time.
It takes 9 hours just to say, "Hey, are you okay?" 9 hours later, the spacecraft goes, "Yeah, I'm here, what should I do?"
We all felt that sense of a ticking clock.
People were sleeping on desks, people were sleeping on the floor and eating out of candy machines.
This is our mission. We have flown 9.5 years, and none of us were going to give up. None of us.
After 3 grueling days, the team waited for New Horizons to respond and find out if they'd saved the mission.
PM, Mom, on Pluto 1. We saw that the spacecraft had transitioned into that mode to accomplish the flyby, and it was pretty amazing.
Our team rose to that occasion with no preparation and saved the day.
With the flyby sequence initiated, New Horizons turned towards Pluto.
When people ask me what my favorite picture is of the Pluto system, it's that blurry picture, the first one that comes down on July 7th. That's a representation of what we had accomplished and what we were going to accomplish. It's one of those moments that you will never forget in your whole life.
I had been working my entire career leading up to this moment of time.
On July 14th, 2015, New Horizons signaled to Earth that it had successfully flown by Pluto. But the team had to wait 9 more hours due to the vast distance between Earth and Pluto to find out if they'd achieved their goal of photographing this far-off world.
So there we were at Johns Hopkins Applied Physics Lab with all the press and the family and friends and a whole bunch of people who were just dying to know what Pluto's like.
When we finally got that image down and we displayed it on the monitor, it was unbelievable.
the whole team was like aghast at this beautiful image.
In 1989, a small team of young scientists took it upon themselves to campaign for a mission to Pluto.
We have to just send it out and take those pictures.
To be able to see this object that no humans really could glimpse.
Over 2.5 decades later, they had achieved their goal and made one of the most unique discoveries in the history of space travel.
It was just extraordinary. This was a whole new world.
Just as Voyager had revealed Neptune's moon Triton, New Horizons images showed a world that was geologically active.
We began to see all of these features.
Mountains and ravines and glaciers and all sorts of indications of activity and physics taking place on the surface. It just blew us away.
Pluto has mountains, but these aren't ordinary mountains. These are mountains of ice, water ice, that are sticking up the size of the Rockies, huge, big mountains.
And Pluto, as Alan is always saying, is the Everest of the solar system. The farthest and coldest and hardest to reach. And so these mountain ranges were named Norgay and Hillary after the original explorers of Everest. Many of the features on Pluto were named after famous explorers and famous vessels of exploration.
As we were flying up to Pluto and imaging it day after day and week after week on approach, we could see this bright feature on the surface. One morning, we got an image back, and as soon as it came up on the big screen, I remember a NASA official who said, "Do you see that? Looks like a heart." And as we got closer and closer, amazingly, it looked more and more like a heart. I think that's what emblazoned Pluto into the public mind as this amazing place at the frontier of our solar system.
Pluto's heart measures 1,600 kilometers across and is composed of nitrogen ice.
We believe that structure might be supported by water underneath the surface. There could be an ocean underneath Pluto's surface.
There probably is some kind of liquid water ocean. It's very deep down inside, but we think there's a pretty good chance that it's there.
It's one of those things where if you find water, is there a chance for life? Wouldn't that be cool if Pluto is actually one of those places in the solar system that has or had life on it, even out at the outer reaches of the solar system? That's just mind-blowing right there.
When we flew behind and we looked at the sun go behind Pluto, we saw this big ring of blue sky, a haze in the upper atmosphere.
New Horizons continued further into the Kuiper Belt. And 3.5 years later, on New Year's Day 2019, it reached a small Kuiper Belt object officially named Arrokoth.
with a spacecraft now 1 billion miles farther out than Pluto. Here was this fantastically complex object.
It's in a very special category of objects out in the Kuiper Belt beyond Neptune. These are objects we call the cold classical objects. These are objects that are in very flat circular orbits that are all traveling around the sun pretty much parallel to each other. They very rarely run into each other. And they clearly have been in these orbits since the formation of the solar system. That's the only way they can have such undisturbed orbits.
These are the building blocks of solar system formation. They're the things that didn't get accreted into the giant planets and the terrestrial planets. So they're the leftovers out in the deep freeze of our solar system.
The images revealed that Arakoth is made up of 2 objects that are joined together.
This can't be done without a very, very, very slow merging of the 2 objects.
Realizing, boy, this is how you make planets. You have to take small objects and bring them together gently so they will stick and won't just smash each other to pieces. And so you can build up things into larger objects and eventually end up with things the size of the Earth. And here we were seeing that process for the first time in a real object that had been frozen in the early stages of that process.
Super exciting to be able to take science by leaps and bounds just from a short period of time where we're getting data.
The outpouring of interest was an amazing thing to see, and just goes to show that this kind of exploration can really bring people together no matter where you are in the world.
I don't think words can really capture how much this mission means and how much of an effect it has had on my life.
Do what you're passionate about. Don't do something because it's easy.
This was something for the post-Voyager generation, that they could say they were there, just like the previous generations could say they saw the first landing on the moon or the first flyby of Jupiter or Saturn or Uranus or Neptune. This was their first.
We've opened up a new realm of the solar system, a new realm of human discovery.
A half-century-long endeavor that will forever be a legacy of our time. We changed the world a little bit for the better, and we made a little something called history.
There is no end to the discoveries that we can make out here in the solar system. We are just getting started.
I gave lots of talks to the public, and I've been to many schools, and it inspires young people to study science.
When you have a dream, something in your heart, you should follow your heart. I never grew up thinking that I would be a part of something like that, but now looking back, I realize everyday people make history.